Hello friends, as I promised you earlier, I have prepared for you a more detailed video about the sound of plasma in a magnetic field. It's time to talk about this device in more detail. I'll start with the diagram that you see on the screen right now. The chip is the NE555 timer. The circuit is a rectangular pulse generator with a frequency of 114 kHz with the possibility of frequency modulation. I connected the output of the chip to an oscilloscope. See what happens. Now you see a carrier frequency of about 114 kHz. Now I will send an audio signal from the phone and see what happens with the frequency. There is a frequency shift. It may seem that this is a PWM signal, but in fact there is a frequency change. This device, which I made on a homemade board, is essentially a field effect transistor driver which is controlled by a sequence of rectangular pulses. A voltage of about 10 volts is applied to the gate of the field effect transistor in the form of a sequence of rectangular pulses. A field effect transistor is just the kind of device that understands only a sequence of rectangular pulses. He doesn't understand anything else. That's the way he is. The field effect transistor can operate exclusively in the key mode. Therefore, a clear rectangular sequence of pulses is needed, otherwise the field effect transistor will not survive. He will just burn up. Either it will not close or it will not open if instead of a sequence of rectangular pulses you give, for example, a noise signal. I mean, if you want to make such a device, it would be nice to have an oscilloscope. Do you have an oscilloscope? Write about it in the comments. Let's try to understand the essence of this device. Half the sound is formed after all. Let's look at the diagram again. And so there is a field effect transistor in the DC circuit. A sequence of rectangular pulses from the NE555 chip enter the gate of the field effect transistor. As a result, we create a short circuit current in the primary winding of the transformer for a short time. That is, a field effect transistor is needed in order to obtain a pulse current in the primary winding of the transformer from DC. We are talking, of course, about a lowercase transformer. The pulsating current in the primary winding creates a pulsating magnetic field, and the pulsating magnetic field creates a pulsating magnetic flux, thanks to which EMF is induced in the secondary winding of the transformer. Therefore, the change in the magnetic flux is not equal to zero. Think about what will happen to the transformer if only direct current flows in the primary winding. Write about it in the comments. Thus, I have the right to say that the field effect transistor in this circuit turns direct current into pulsed current. That's exactly what we need. But how it is the sound created? I can assume that this is due to a change in the carrier frequency. Let's take a look in slow motion. What is the sound of the plasma? I managed to capture only one of the plasma cores since slow motion cameras require very intense lighting. So what created the sound? Previously I assumed that the sound is created by the expansion and narrowing of the discharge, but now it causes reflection. What do you think about this? Write your answer in the comments. I also observed a very interesting kind of discharge in this place which resembled the light of San Telmo. Everything you saw concerned the discharge in the magnetic field. I just connected the anode to each neodymium magnet and got such a beautiful cone, which you previously saw in the photos. It seems to me that the shape of this cone can be used to judge the magnetic properties of matter. The cone gradually begins to decrease, which indicates a strong heating of the neodymium magnet. And it was in a magnetic field. And what will happen without a magnetic field? Instead of a magnet, I put a copper cylinder, and as you can see, the plasma cone has disappeared. Let's look at it in slow motion. As you can see, when there is a magnetic field, the shape of the discharge is different. Let's look at the main nodes of this device. I used a computer power supply and the NE555 chip from 12 volts, the fan and the power part of the IRFP 460 transistor, also 12 volts. Remember, the higher the carrier frequency, the more voltage will be required for the NE555 timer. The next device is a lowercase transformer, which should be together with a built-in voltage multiplier. This allows you to obtain a sine constant voltage. Of course, you will need a radiator with a fan, since even such a massive radiator heats up a lot. This cooler does its job well. You must need some connecting elements to connect an MP3 player, phone or computer, as in my case. That's all for now. Send your ringtones. I will try to play your song on this device. device. Follow also my channel in Telegram. I will leave a link to the channel in the description of this video. All by sincerely Yuri Kovalenko.